clear. Sauti iko chini.
Iko chini, but it's clear.
Okay, let me. Sahi?
Yeah, it's louder.
Mm.
Yeah, it's much louder. A bit of noise, but it's loud enough.
Okay. So I'll just share my screen.
Okay.
So can you see anything?
Yes, now I can see your slide.
Okay. So um, good evening. So I'm Western Onzere, and I'm an machine learning, or nowadays we call ourselves AI systems architect. So my field generally is about AI, and today I'll actually be sharing with you something 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 to do with the AI agents. So I think I was a speaker in the last event. Then one thing I realized that I was most of the guys were from the infra field. So during that time, I was able to engage with some of you. It was nice. It was a nice meetup, and it also challenged me because most of my work is all about, or what we essentially do is actually building the backend stuff, things to do with that. Then I think from there, one thing I realized is that we have the developers. Then after the devs, we hand over our work to the infrastructure guys. So I think that is where you actually come in. So today I've prepared something to do with agentic systems and how the guys from the infrastructure side of things can actually uh, utilize some of these AI systems that are being developed to actually make their work a little bit easier, simpler for them to actually maneuver. So that is what I'll be talking to you about today. So one thing that I think most of you, if not all of you, are synonymous with the large language models. Okay, so when you're talking of large language models, so these are essentially AI systems that are actually trained on vast amounts of data. So just picture this as the internet data. So we collect that data, we version that data, and we use that data to actually train these AI systems so that they can able to learn whatever they're able to learn from the patterns of this data in order to actually generate something new from that data. So picture this, that you are going to ChatGPT, asking ChatGPT to try and explain a concept, something like that. So it's able to pick whatever you're asking, then it's going to, in its memory, or whatever we have actually trained that AI systems, the data. So it's able to pick that data and actually use that to generate a question based on the query that you're asking. So one thing about the large language models that we came to understand is that, okay, we have these large language models. How are we going to actually utilize these large language models to maximize their importance? Okay, so that's where different types of things actually started cropping up. I think we started with the RAG systems. I think we are also going to talk about that today. Then from there, things escalated to things to do with AI agents. Okay, so when you're talking about these LLMs, so one thing that I think most of us have actually used these LLMs. They're actually incredible when it comes to tasks involving text generation, summarizing a text, or generating a text based on an input query. Okay, so these systems are quite excellent when it comes to such systems. But when you want to apply these LLMs for complex workflows, then they tend to not to perform to our expectations. Okay, so that's where now AI agents actually are coming. So when you're talking about AI agents, these are we are essentially incorporating the large language models. Okay, so we have the large language models. Then we add additional tools to these agents. Then we provide some sort of memory, because memory is very important for these large language models, because you need to store data or information from some place. Okay, so we need to actually have some sort of memory that you're feeding it, or the large language model is actually going to access. Then we need an environment, an orchestrating environment. Our agent has to be performing or carrying out tasks within a specified environment. And then we have to define a specific goal. Okay, so a goal is very important for this agent. So when you're talking of these agents, just think of something to do with the memory, the environment, the defined goal, and the agent itself. So as you can look at the image, so we have the memory component, we have the tools component, we have the goals that or activity this agent is going to be actually performing within this predefined environment. Okay, so having an LLM and also providing these necessary tools, we come to realize that these agents actually transform from not just being a simple tool that can just answer a query or a question that you're asking. So they be able to transform these agents to become these entities that can actually perform some activities perform some activities. So they can query a database. So if you need some data, an agent can actually perform that data. So that means you won't be requiring every now and then to be making those requests. So an agent can actually perform that work for you. They can trigger some API calls and even can hand over tasks from one agent to another. So an LLM by itself, let's say a ChatGPT by itself, then it has what I'll say, it is limited in one way or another. But now, if you infuse agents within those large language models, you're able to actually utilize, you're actually able to maximally utilize those LLMs. Okay, so with LLM, now essentially with the large language models, so the large language models, the ChatGPT, the cloud, Google Gemini, all those, they actually provide us with something that I can just call it a brain. So the LLMs provide us with the brain component. So the brain, that means we're able to the reasoning capabilities, as well as the conversational capabilities. Be able to interact with the LLM, be able to ask it a question, and it's able to give you a response back. So that's some type of interaction. Then an agent, now transitioning from the LLM to an agent. So agent becomes this awesome individual. So picture this, an agent just mimics an individual. You picture you as that individual. Now, where you have the brain to reason, okay, you have the memory for that. Then you have additional tools to actually perform some activities within this predefined environment. Okay? So from LLMs, I think one thing that so this one, I'll try to squeeze this now. Let's switch now to the infrastructure side of things. Okay. Now, from large language models, there's previously I talked about LLMs being you're just training these models using internet data. Okay, but you see in some cases where we actually need specificity, we cannot just rely on what LLM is actually generating. If you are working within an organization, sometimes you have in-house data, and that data you have not actually exposed that data to for everyone to actually access. Okay, so you have private data or that only works within your organization. Okay, so one thing that when these models were being generated, they were forced to answer this question: what if we have our private data? This data we don't need to expose it to the entire internet. Okay, so what if you have this type of data? How are we going to maximally use that type of data to actually help us as our organization. Okay, so that's where the retrieval augmented generation actually came in. So this is, in short, it's a RAG system that actually contains the retrieval component, the augmentation component, as well as the generation component. So when you're talking about the RAG system, so this one actually bridges the gap between the static knowledge and the dynamic domain-specific data. So static knowledge is like internet data. Okay, so let me use an example. Let's say if your large language model was only trained to, let's say, up to, we are in the month of October. Let's say it was only trained to data until the month of September. Okay, then you try to ask the model a question about an event that has actually happened in October. Okay, so because the cutoff knowledge is up to September, the model is not able to access data, the updated data that is in the month of October. And that's why the retrieval augmented generation comes in. So because our in-house data, we consider our in-house data to be that type of data that's up to date. Okay, but the LLM data is not up to date according to our in-house data. So we are able to augment that by providing the large language model with our in-house updated data, so that whenever we ask a question or whenever we retrieve something, it's able to pick whatever data it has, and also whatever data you are also providing, in-house data you're also providing, and by that you're able to change our system from a static model to this dynamic and domain-specific data. One thing with this is that you can also constrain the large language model to say, okay, when giving me responses, I just want you to actually use this type of data. Okay, so that's why the retrieval augmented generation system is actually important. So with this, we have seen that we are able, with the RAG system, we are actually able to retrieve the most relevant information up to date. And then when giving these answers, we are able to actually ground your answers because of the factual information, the domain-specific information. You're able to ground your responses based on that a system. So picture this, that you are working in the legal domain, or the finance domain, or even DevOps assistant, which I think most of you are. So let me use an example of your DevOps. Okay, so I'll maybe use Angani for example. So Angani has a way of actually whenever a ticket is raised, it has a way to actually solve that ticket, or that's a way that maybe specific individuals who are specifically suited for, let's say, if there's a problem with the networking. So there are maybe individuals who can actually solve that problem. Or if it's a problem with the API issues, then maybe there are a specific team that can actually solve that problem. So how can we actually use the retrieval augmented generation system to actually help those assistants actually solve those problems with ease? Okay. So essentially what we can do, we can actually collect that information about previous cases or any type of documentation within that organization. Okay, so we can collect that information and actually store that information within a database, so that whenever a query, any assistant is actually wants to solve a problem, okay, they're able to query the data. Then with the help of the large language model, it's able to elaborate more based on that information is being provided. Okay. So what are the core components when you're talking about the RAG system? So with the RAG system, I think we had the retriever element, we had the augmenter element, the generator, and also the knowledge store. So the retriever, so when you're asking a question, the retriever will only go to the database whenever you're storing your information, and only retrieve the relevant information from the knowledge base about that specific query. So instead of your entire library, instead of bringing forth your entire library, it's only going to search within your library of documents, only find or collect data or documents, for that matter, that only match whatever query you're going to ask. Okay. Then once it retrieves as the same number of documents. So, for example, if you're asking a question about, let's say, about a database, so I'm talking about, let's say, a question about MongoDB as a database. Okay. So it's only going to fetch information concerning MongoDB as a database. But if you have other database like DynamoDB or whatever, it's not going to actually retrieve that type of information. So it's going to be specific within the query that you're asking. Then whatever documents you are retrieving, the augmenter actually combines the retrieve data with the user query. So the user query provides the context. So the context, take context as the environment within which we want this information to be conveyed. Okay. With that context, the augmenter actually takes the documents, it combines that with the user query, then it's able to enrich it's actually able to enrich that. Then it passes that information to actually the generator, where it actually produces the final coherent context-aware responses based on that. Okay. Then this information that we are generating is actually stored within a vector database. I'll talk about the vector database. Okay. So when you have all this amount of documents, okay, let's say past incident reports or past incident reports that you have that some of your team members have actually solved problems. They have actually documented those types of problems when they were arising. Okay, so you have all that amount of information. So what's essentially with the retrieval augmented generation systems, we don't use the conventional databases. Okay, the Postgre, the MySQL. Okay, so there is a type of database, and that is a vector database, simply because computers do not necessarily understand the words as we type them. Okay, what we need to do is to convert words into numeric representations. Okay, and those numeric representations will now be stored within a database. Now, with the vector database, it's quite handy in the sense that we are able to take documents that are of the same domain or of the same semantic meaning and house them within uh, a specific site or a specific section within the database, and so on. So, for example, as you can look in this image, let me see if I can use a highlighter. And just use a pen. So on this side of my screen, you can see we have animals, wolf, dog, and cat. So because these are actually animals, they are housed within a section of the vector database where they contain a semantic similarity. Okay, and on your right hand side, we have banana, apple. Okay, so these are fruits. Again, you can see they are housed within a different side or section within the database. So this one is very important because when we are searching through our database, because again we have vast amount of data, we need to find a way to source that information so that we're able to retrieve whatever is relevant to what I'm asking. Okay, so having this type of database, we're able to enable that type of similarity search. Then because of that similarity search, then we're able to do fast search and context-aware retrieval. That means we're not just pulling documents because we want to pull documents. We're pulling documents that are in line with what we essentially need when trying to answer a specific question. Okay? So this is an example of a RAG pipeline. So again, I think I've talked this lengthy. So with the RAG pipeline, so you have your in-house documents. So consider this as the source knowledge. So these are all the manuals, the wikis, the logs, the reports. Even if you have the in-house, all types of documentation. Okay, if you are deploying a system, maybe there's a type of documentation based on that system that you're deploying. Okay, so all that is any form of document that we can use. So essentially, once we collect that documentation, once you collect that documentation, you can see it's document that is quite, I can say it's not well arranged. Okay, so we need to sort and index all that type of information. And once we do that, that is the process of chunking. So we are chunking. So this is the process. So the process of chunking. So this is the process of, so we are taking that document and breaking that document into small sections, and these sections have a semantic meaning. So for example, if you're talking about how to deploy a database, okay, so you can collect that as a chunk of information that offers us a description about how to create a database, okay, things like that. Then once we split our documents into this, so these are the chunks. Once we split those documents into chunks, we need to now convert all those documents into numeric representations. Okay, so and that's the process of embedding. So we can use we have many embedding models. So we can take our data, combine, embed those data, and then once we embed the document, then we are going to store those documents as vectors. And from the vectors, again, here you can see, for example, any document concerning company, we are storing at this point. Then for finances, again, they have a specific, or how we are going to store those documents. Okay, so this is how we prepare our documents. Then we embed, and then we store those documents into chunks. Okay, so once we have prepared our documents into this component, now that's where our RAG agent actually comes in. Okay, now because we have prepared this agent, we have prepared our data and all that. How are we now going to actually include an agent into this system? Okay, so when you're talking of the RAG agent, so this one acts as an intelligent layer on top of the RAG pipeline. So once you prepare the pipeline, we add on top of that the RAG agent. Okay, so with the RAG agent, what you are going to do is that it doesn't just retrieve the documents. Okay, one component with the RAG agent is that it's able to actually offer some type of reasoning on top of that. So when a user asks a question, the agent checks if it has enough context. Okay, and if not, it actually queries the vector store that you have talked about. It's able to query the vector store to actually retrieve those the required documents to actually answer that question. So another thing with an agent, because we talked about LLMs, and we say that LLM provides us with the reasoning, the brain component. Okay, so with an agent, because it's an LLM having the mind to actually think, it can actually break down the complex problem into simpler steps. Then it's able to retrieve the right data, synthesize that data, and actually give responses that actually are grounded in facts. Okay, and over time, because this agent is not just static, it's dynamic. It's able to think with more data, so it becomes more accurate as a feedback for us to actually use this agent. So this is a typical example of a RAG agent. So for example, you can when a chat is received, when a chat is received, then we have an AI agent. So this agent is the tools, it has the tools and everything. So we have the model. This is an LLM model, Open AI model. So this is a memory component where we are storing this data and all that. Then we are providing our agent with additional tools. So we have providing it with a a Gmail if you want to send messages. If you want to actually create, for example, this meeting, let's say you just want to create a meeting, you can actually liaise with your agent. It can get a chat message. Yes? Sorry? Question? Yes, yes. Are you getting?
Did someone have a question? Okay, I think we are good. You can go on, Western.
Okay, so I'll try to explain this as a RAG agent. Okay, so this diagram is this diagram actually represents a simple agentic architecture, and this one I'm just making it simple. I'm using a single agent with additional tools. So remember previously we talked about an agent having memory, tools, and environment, things like that. Okay, so at the center we have our agent. So this is our let me use a pen. So this is actually our agent, which serves as the reasoning and the orchestration unit of this agent. So when a user sends a message, okay, the agent actually interprets that question. So what is the intent of this user, or what does this user wants to find out? So for example, you're dealing with a Kubernetes cluster, okay, and you actually need to find more information about Kubernetes and how within your organization you have been deploying you have been monitoring your clusters and all that. Okay, so the agent actually takes that as the chat message received. Then your agent will interpret the intent and determine which tools are actually needed to actually accomplish this task. So the chat model provides the agent the core reasoning ability. So that means it's able to understand the context, make decisions, and actually regenerate your natural responses. Then we have the memory module. So with the memory, it allows the agent to recall the previous interactions. Okay, if you have some previous interactions, that means when you're creating your stack, is that you have this memory so that you're making your model to be static. It's able to recall your previous messages so that it's not breaking when it's trying to give you the responses. Okay. Then we have here you can see we have additional tools. We have contacts, Google Calendar, Gmail. So, for example, if you want to contact your clients, something like that, then you have a list of your contacts within where the agents can retrieve that information. Then it can send them emails whenever it's needed. Then a calendar is also an additional tool if you want to set meetings and all that. Then your agents can actually, if your question is about setting up a meeting, so you can just type your question. I need you to set a meeting on 25th October, okay, at 8 p.m. Then agent will take that message. It will see the intent. Then because you've provided the tool as the Google Calendar, it's able to actually create uh, that event for you. Okay, so I think I've talked a lot about the RAG agent. So I think from here I will jump into a demo so that I'll be able to see how our agent can actually, how we can work with our agent in production. But before I can talk about this, then maybe if someone has a question, any concern, that I can elaborate on that before we start working on this. Maybe something that you want it to be elaborated. Then before we
Okay. Thank you, Weston, for the information and for clearing up LLMs and LLMs and agents.
Mm.
So let me see. I see somebody's hand. Let me see that hand that's up. Okay. Just a second.
Mm.
Somebody's hand is up. I can't see their name. So just please unmute and ask your question. Okay. You have put your hand down. So I don't know if that was a mistake or not, but that's fine. So yeah, maybe on the chat there's been, oh sorry, someone is saying a minute. Are you ready to ask the question now? Okay, as we wait for the person, I can't see the name. So on the chat, I had asked maybe a few questions.
Mm.
So when you're showing the demo for the agent,
Yes.
so what triggers the whole agent system? So is it at least from a dev perspective, because
Mm.
usually you have an action or something that triggers the whole system. Maybe you can explain a little bit about that.
Okay. Now, from that perspective,
Yeah.
we have trigger. So let's say you have uh, you have deployed an application, yeah?
Mm-hmm.
And within that application you have embedded, what can I call them? I'm forgetting the name. It's like it's able to log information about how it's working. I'm forgetting the name for that. Um, if I may ask, have you ever used is it Prometheus and Grafana?
No, but I know about them.
Okay, so we are able to use those tools to actually monitor our applications. Okay,
Okay.
so when you are monitoring your applications, you are able to get some detailed information about how your application is actually working in production. Let's say if uh, there is a security breach, then it's able to notify you that some person tried to access your database, something like that. Okay,
Okay.
so those are the information. That is the type of information that you're able to get from your application. And once we collect that information, it's able to actually trigger your agent to it's able to actually trigger your agent to actually act on that information. Let's say you are is it Kubernetes cluster, okay? Or let's say you are is it cluster or a pod?
Yeah, you
I
can, you
think it's
can.
a pod. Pod if it's failing, okay?
Yeah.
Yeah. So you are able to it's able to collect that information, and if your pod is failing, then it's able to send that information back to you, and then that triggers the agent. It picks that information. Then within your database, for example, let's say there is a person, let's say Peter, for example, is the person in charge of monitoring that. So it's able to collect that information and then pass through your database, finds the person who is in charge of such issues. Then it alerts them directly, telling them that okay, this is the problem that you are having, and you're the person in charge for this. Okay, so you need to sort this problem. Actually, within this workflow, I've tried to represent that. So with this workflow, I'll first take you through before I can execute an example for this. So with this with this flow, you can see we have this chart. Let me try. Okay, so I have this this chart. So this is like a trigger. So you can link this to your any tool that you're using to collect metrics about the applications or any systems that you have deployed. Okay, so this one will be like a web, something like a webhook things to, yeah, I think a webhook, something like that. So whenever information is coming in, you're able to collect that information, and I'm able to store that information within. For my case, I'm using Google Drive, but you can choose any type of database. So you have various databases that you can actually choose that. So you have I think, let me see, database. You have Mongo, yeah. So you have different types of database that you can use. Postgres, yeah. So depending on the type of database that you require, you can select different type of database to actually store that information. So whenever a query or a problem is arising from your application, you're able to collect that and store that information within your database. Okay. So once we store that information, then what we need to do is that we need to now convert that information into a numeric representation using, and so that those representations within a vector store. And that's why now the embedding models actually come in. So for my case, I'm using this is Mistral. This is an embedding model. So you're able to take that problem or issue that is coming, then you're able to actually converting that into numeric representations, and then you're actually able to store your numeric representations. So for my case, I'm using Superbase as my vector store to store that information. And this one here, this one is just a data loader. So for any information coming in, you first have to use the data loader to load that information to first to your vector store. Then the embedding model will take that data and convert that into numeric representation, and again to just store within the vector store. So that is the initial process. So I think in my slides I talked about the pipeline itself. So this is the initial pipeline. I can just highlight it. So this one, this is your the pipeline, how you are getting your data, how you're preparing your data, and how you are actually storing that data within your vector store. Okay. Now from here, that's where the AI agent actually comes in. Okay. So before I elaborate more about the AI agent. So I have data here. So this is some sort of data. Let's say this is about the documentation about how you're running things within your organization. Okay. So let me try to expand this. So this is so let's say data is coming in. You're taking that data and preparing it so that our model can actually utilize it for the purpose, for whatever purpose you want to use it. So the content or the data the data that we are storing, this is some sort of documentation about how we might handle security issues that are coming or security issues that are arising. So this is a security incident response for TSL certificate expiry verify using. So this is a command that you can run. Okay. Then if it's an issue about this is an issue about security, if it's an issue about API, so you can see we have some content about that. API gateway troubleshooting. So if latency spikes are observed above this, endpoints first validate the upstream latency. Okay, so this is some sort of information of how we can actually, based on previous cases or problems that we have actually solved. So we documented that information, and we're able to store that within this type of content. Okay, so when we store it in terms of content, so this is the content that's actually going to be, this is the content that we're going to embed, and then this is the the metadata that you're going to attach to that content, so that whenever you're able to retrieve this information, okay, then we're able to see the type is documentation. If it's a topic about API, so this is about API gateway troubleshooting and performance tuning when it comes to issues about API. And one piece of information that we are also adding is about this. This is the principle. So you can see in our principle, we are noting someone who is within our team department who is responsible for these types of issues. So here we are passing the name API lead to be like James Okello. Okay, here we say it's about security, Cisco Sarah Patel. Okay, so we can have numerous data about this, and in each we are specifying that for this problem, this person is in charge or something like that, so that whenever we are going to route this query, we're able to route this query and it's going to land at the desk of a specific person who is best or who within our department handles these types of errors. So these are the type of data that I primarily used because I haven't built an application. So this is the data that we are going to use to that our agent is actually going to act on, so that whenever we type a query, it's able to search through our database, find within our department or which type of issue is close to the query that you're asking. Then it's going to respond. And then if maybe you need further guidance or something like that, then it will attach the name of the individual, the person who is mostly in charge of these types of issues. Okay. So these are problems just to do with about, you can see infrastructure, DevOps, okay, monitoring, networking, cloud. Okay, so those are types of the issues. Those are the types of problems that I thought of when coming up with this type of data. So for my case, this data will be stored in my Google Drive. Then I'll just import this data. But because I did execute this previously, at the moment, what I'll do, instead of running this twice, I'll just execute it once. So then just execute. So I'll execute this flow so by executing the workload, so it will upload the data. Then you can see a default data loader. Then it will load the data. Then we first do the embeddings. Then after the embeddings, you're going to populate our Superbase vector store. So where we're going to store all this information. And this information will be stored in terms of numeric representations. So I think I'd executed this flow previously. I'll just show you how it looks when you're in your database. So when you're in your database, you can see I have my content. This is the content. This is the metadata assigned to that content. So this is the content itself. You can see for security incident response, for TSL certificate. So this is the data. Then this is the metadata associated to that content, and then the embeddings. So these are the, let's see. So this content has been converted into numeric representations, and that is the embedding vector. Okay, so this is the embeddings vector. So this is the resultant of converting our textual information, converting this textual information into numeric representation, because our agent won't be seeing words, but it will be seeing numbers, okay, as our embedding model. So once we have converted that, I think this one, I think it has executed okay. So you're clicking this to execute your workflow. Then we import our data, then convert that data into numeric representations. Okay. Now, once we have our data in store, now it becomes easier for our agent to actually start working. Okay. So I'll try to explain about the agent itself. So this is where our agent now comes in. Okay. So remember, we have our data stored, our data in a vector store. Now let's kick in the agent to actually help us. So picture this, that let's say an issue about, so I have several queries here. So there's a problem. Let's say there's a ticket coming in, and for this ticket, it's something to do with sorry, just type the message here. So this is a message we are getting SSL certificate expiration warnings on the production load balancer. Okay, so this is a type of problem that you might be encountering. Okay, so now when we have our AI agent, okay, so we have our trigger similar to what we did earlier. So this is our trigger and it's the message. So picture this, that this is the message that is coming in. Okay, so when the message comes in, we are not sure who is supposed to handle this ticket. Okay, we are not certain. So what our agent does is that it takes this information, then it will again. So you can see, I'm supposed to link this to supposed to also access. Okay, yeah, supposed to actually access the vectors too. Anyway. So what our agent does is that we also need it has to access the information that we have actually stored within our database, so that when the query comes in, okay, so this is the query that is coming in. Then the query comes in. Then we have our LLM. So I'm using at the moment I'm using a Grok. So this is our LLM that is going to answer that query. So the first thing that is going to do is going to route this query to the specific department and then give us some information about, based on the documentation that we have stored earlier, on how this problem can be sorted out. Okay, so what I'm going to do is that I'll again just, so this is the AI agent. Then previously I talked about the memory component. So this is the chat memory. So when you're chatting with the agent, it's able to store your conversation so that every conversation does not seem to be a new interaction. Okay, so you're making our agent to be actually stateful. So I'm going to answer the request. So you can see it's going to, we started with the Postgre, then the agent, then the the Grok actually it's able to answer that response. So let's see what is the response that we are getting. So this is the output similar to this. These are the steps that the agent took while giving us the response, and then this is how the agent was trying to reason out that 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 query. Okay, so you can see them. Don't know if you can see this. Let me try to expound this. So you can see here. Let me try to expand on this. So you can see the mode is routing. So it's able to route that query. Then it's able to route that query to the team. So maybe you have the backend team that is supposed to handle this query. Then we have the priority. Is it a medium priority? Is it a high priority? Or is it a low priority? Okay. So you're able to answer these responses based on how serious is this problem. Okay. Then you're able to give a reason as to why we have routed this query. So the reason, error message indicates a deployment issue with the microservices, which falls under the backend team's responsibility for managing application logic and the microservices. So again, this is the reason as to why we have routed this to that. Then deployment troubleshooting. So you're able to actually find some information about this. So run Docker compose, verify this. So this is the information that is based on our documentation. This is the information that is synthesized from this documentation. So it's able to find things to do with the backend. Okay, so it's able to find issues to do with the backend. then read this information. Then based on the query that you're asking, it's able to curate some form of a response that okay, if I get this issue, then at least I have a basis from where I'm going to start when trying to solve this problem that is actually arising. Okay, so I don't know why I try to. So if I think in my during in my talk I think so essentially what I was trying to do, I was depending on the complexity of whatever of how you're going to set up your agent. So in my previous one, I tried to customize, write the code for how you can create your agent and how it's going to route these queries, or how it's going to route these queries. But you can essentially try to use additional tools. Like this one I'm using is N8N, where you can just create how you want your information to actually flow between databases, different teams and all that, and how it's able to actually help you sort those problems when they are arising. Okay, so you can ask. So I had a couple of a question. So if it's a thing, something to do with the database, then the agent will just ask a question. Then again, you can see progress chart. Then the agent is able to answer that. Then it's able to give you a problem to do with that. Okay. So depending on how you have curated your data, how you are cleaning your data, how you're processing your data. That is a vital tool to actually making these agents actually work better. Okay, so the more data that you have, the easier it's for the model to actually generate better responses and all that. Okay, so I think I don't know. I think I have the vector store. No, supposed to retrieve. Let me see. There's something small. Okay, so I think don't know why it's not. What I wanted is that when you are generating the response, is that what I wanted is for this name for a specific person to actually appear. Okay, but don't know why. Maybe it's more cleaning and configuring it better. But that's it. So if you have a database issue, so again you can see it's able to route. The mode routing, database priority, medium, reason, it gets a replication lag issue, which falls under the database team's responsibility for handling query performance and replication. Then for database performance and troubleshooting, then it's able to give you information about how in-house how previously you have tried to handle these issues. Okay, then at least by this you are having that basis to actually be in a better position to actually sort the said issues. Okay, so I wanted I don't know why it's failing, but I wanted for it to actually show the principle or the name, so that whenever you're the new guy or you're the new team member, in case of such issue database, you can find out, okay, this is the person who I can consult, so that they can help to actually sort or solve this problem. Okay, so I think uh, that's it. That's it from my from my side. At least today, sijakwama kama previously. So I think today, I think it worked on my side. So that's it from my side. Thank you.
All right. Thank you so much for the demo. I think it's made a lot of things clear. And like you have said, if you're the new person in the team, it's easy to know who's responsible for what. And I think from your example, that's something that you can even take a step further and say, oh, so I've asked the question and the agent has told me I need to talk to somebody, and then the agent can even perform more actions, right?
Yeah. So because I was limited in terms of data, So if you have more data, okay, then it becomes very easy to actually just build a system like that. Then if you want more, this is the person responsible for this, or even if you want uh, forgetting the word itself. Anyway, but I think you can now understand the concept of how that agent can actually help you within your organization, organize your work, organize who's going to handle what, and so on.
Yeah, awesome. Cool stuff, good stuff. So I don't know if you have any questions. I don't see. Yeah, somebody's hand is raised. I don't know if it's equal or equal. Please feel free to unmute your mic and ask your question.
Okay. Thanks so much for the talk.
Yes.
So my question is, like, if I wanted to have it in multiple languages, so for example, if the question comes in as, if you have the database question, it comes in French.
Yes.
Do you have to translate the internal documentation to be in French yourself, or you can just leave that to like the LLM to do?
Actually, we have, if I can just go back now, for the LLM, I talked about an embedding model. So for the embedding model, this one here, this one you can use a multilingual embedding model, so that it doesn't matter if a question is on French, Spanish, okay, it doesn't matter. So what it does is that it will take your query. If you want your response to be in English, then it will just translate the final response to English. If your query is in French, okay, then maybe your documentation is in English, and maybe you want an English response. So having a multilingual embedding model, it's able to embed it in French. Then it will just by itself do the interpretation, and then your final response will appear in the preferred language. Of course, before we generate your response, again you can add another step. Maybe you want your response to be in Spanish, English, French. Okay, it doesn't matter. The agent can actually work around depending on how you want your response to actually appear. So you're not bounded by the type of language. Okay, whatever language you are using within your team, it's actually able to actually generate information that will be suitable within your team.
Okay. I get that. Thanks.
All right. Thank you for the question. Anybody else with a question? All right. So we have some questions in the chat. So we have Joseph asking, is RAG agent able to handle misinformation? If yes, how?
Okay. So I think you have had the concept garbage in, garbage out. Okay. So because previously I talked about large language model being trained on internet data. Okay. So for the internet data, we cannot decipher or learn or find out what is misinformation or what is factual information. So what RAG systems actually enable us is that we have our in-house data, and that's the data that we want our LLM to actually use while generating responses. We can put like a shut. We can shut such that the LLM should not think outside the data that we are providing. So we are constraining the LLM to actually use this specific data to generate your response. So because organization generally trust their own data, so it will be very, we cannot say it's 0%. So you'll have reduced you'll have reduced the a problem concerning the misinformation, because you are constraining your LLM in terms of what information is going to use while generating a response. Okay, so I think with the LLM, with the RAG agent, you are actually able to reduce misinformation. So I hope I've answered you.
Okay, I hope, Joseph, your question has been answered. We also have a question from Denson, who wanted to see an example of a vector database. Are you able to show that?
Yes. So, okay. Let me see. So this one is Superbase. I think Superbase. Is it a Postgre? I'm not wrong. It's a Postgres database. So this is a type of vector database. So whatever information that you are concerned with is this embedding vector. So this is the type of information that we are mostly concerned with. So previously I said is that from the vector database, we have our let's say we have the content itself. So because when they're doing a semantic search, computers generally don't understand this type of language. Okay, so we have to convert this information into numeric representations. Okay, and that's where the embedding model actually comes in. So we take this information and we pass through our embedding model. We pass through our embedding model. So this model, because this model, it has been we're using models that have been trained on textual data. Okay, so we take this model, then we pass our text through this embedding model, and then it's able to convert text into numeric representations, such that at the end we have this embedding vector. So you can see it's just numbers. So this is what we now use to actually conduct the similarity search, such that when we ask a question concerning security or concerning database or concerning APIs, backend, okay, APIs, so it's able to filter through our data and look for the types of embeddings. I think I talked about this in the yeah. So we're able to search that information. Then because information concerning APIs or database will be housed within a specific part within the vector database. So we are able to only narrow down. So it enables us to actually narrow down, to actually search from where this type of information is actually found. So for example, let's say this side of things were concerned with the database. So instead of searching the areas that are more concerned about APIs, or let's say we are searching for information concerning backend. Okay, so we are only constraining our search into the side of things where we're only searching for information about database. So for vector database, the only thing that you're going to see is are these numbers. This is the data that you are just going to you're able to see in your vector database. It's a little bit different from the SQL database, the Postgre, the NoSQL databases. Okay, so this is a little bit different from that. So for search and retrieval, the model is only going to search within your embedding. It won't be concerned about the content. Okay, so it will search within your embedding vector. If it finds a vector that is matching your query, so instead of returning the numbers, it's going to return the content. So this content, it's what is going to be passed through your LLM, this one. So the LLM will now receive the content itself, and then it will reason out based on the query that you asked. Then it will now generate the response that you will be getting in your chat platform. So the goodness of this, I think maybe one thing that I can add on that is that you might be using emails. I think emails. You can be using Slack. All those platforms you can actually embed them within your agent, so that if you prefer your communication via Slack or Mattermost or I think we have various. Even if you prefer your communication via WhatsApp, you're able to actually get information pinging on your WhatsApp as a message that, okay, this is happening, this is what you need to solve. Again, you can just interact with your data even via WhatsApp, via Slack, via whatever, even email. You can just interact. The agent will take that information, it will search, give you back the response based on that query. Okay, so I hope I've answered that.
All right. Thank you, Weston. We have one interesting question from Lynette. So she says she was building a project and she built a simple chat interface that works well during a session. But whenever she reloads or restarts the app, all the previous prompts disappear. What's the best way to implement persistent memory so that users can continue their conversations where they left off?
Yeah, so that is the memory component. I think most of the chat applications, I think they are stateless. I think the Linet is actually explaining that problem. So what you need to actually implement is this type of chat memory. So you need to actually implement a chat memory, and this chat memory will actually store your query plus the response that is getting from your LLM. Okay, so it's able to store those so that before the next query comes in, it's able to load uh, whatever were your previous search and responses, so that your model is able to get a better context. Okay, then if your query requires maybe further elaboration, then it's not going to again search the vector store, retrieve documents, and all that. Okay, so for your problem, whatever you're missing is this one, the Postgres, the chat memory. I think that's what you are missing. So what you can do, I think Superbase they can also offer that. I think they can offer that where you'll create a simple database like this, where you'll be storing your chat plus the response that you're getting from the model. Then there's one component that you'll actually need to vary. That is the to what extent do you want your model to actually remember your past conversations? You want it to remember the 10 previous conversations, 20, 30, 100. Okay, so you can vary that parameter such that it's actually able to so you can actually vary that parameter so that it allows your model to maybe forget your yesterday's conversation and just maintain whatever we discussed about today. Okay, so I think have I answered uh, your question appropriately?
Yes, you have. Thank you.
Okay. Anyone the question? Maybe
All right. I think we've answered everyone's questions. Thank you so much, David Westman. I didn't know you're called David. We've called you Westman. For the very, very informative session. Thank you also for customizing it to a more DevOps infra audience so that we understand the examples that you used. So maybe last question, if we want to follow you or if you have more questions like Lynette, where can we find you?
Okay, these are my socials, so you can find me on LinkedIn, then X, you can just Western Onzere, and that is my GitHub link. I forgot to add an email. If you find me on these socials, you're able to find me on this. And then if you have any question, any concern, I'll be glad to actually to help you on that.
All right. So thank you so much once again for creating the time, and we hope that you come back again in the future, or we will. Oh yes, people are clapping. Yes, please do clap for Western now that we have sound on our reaction. And I see Major's hand is up. Major, you have something, and Joseph?
Hello, so no, I just wanted to react to clap and then I raised my hand.
Oh, okay. Yeah, so thank you so much, Western, for your time and for always responding when we request you to come back and share your knowledge. And I think we are free to drop out of the call and enjoy our evening. So thank you once again, Western. We will share the recording and the slides if you need to review anything.
Okay. Thank you. Nimeshukuru. We'll run baadaye.
All right. Bye.
Okay, bye.